collection of stars and the Milky Way फॉर्म हुई है 13.5 बिलियन ईयर्स अगो, राइट। ये मिल्की वे फॉर्म होना स्टार्ट हुई है, अर्ली एरा ऑफ स्टार्स एंड गैलेक्सी फॉर्मेशंस। ना हम ये कैसे देखते हैं मिल्की वे किस तरह से फॉर्म हुई है, क्या हुई है, तो बहुत सी स्टडी की जाती है। फिर हम देखते हैं कि बहुत सी लाइट्स आ रही हैं, रेडिएशंस आ रहे हैं, उन पर स्टडी की जाती है। फिर टाइम पीरियड निकाला जाता है, वो किस तरह से फ्यूचर में देखेंगे, तब उसके बारे में बात करेंगे। आखिर कैलकुलेशन कैसे की जाती है इन सब चीज़ों की, ये 13.8, 13.7, ये सब बिलियन ईयर्स में आखिर इनकी कैलकुलेशन कैसे हुई है, उन सब के बारे में देखेंगे।
By a dense region of gas collected to form a system of gravitationally bound stars. Due to the centrifugal force and accentuated by conservation of angular momentum, this began to spin in the way that it does now, collapsing from a sphere into a disk, and has presumably been undisturbed by major collisions all these billions of years, as its spiral shape has been retained. The older population 2 stars can be found in the halo from the time of the galaxy's formation, whereas most stars in the disk are younger, more likely to be population 1 stars, formed after the galaxy had already begun to take its current shape. An estimated 3 to 5 stars per year continue to form today from all the interstellar gas and dust. Eventually, all the stars that can form from the gas and dust will have formed, and many will die, predicting a grim, dark fate for the galaxy in some several hundred billion years. But there is much more to talk about regarding the past and present first. Sometime into the existence of the Milky Way, a little less than 5 billion years ago, a cloud of gas and dust full of heavy elements dispersed from the depths of population 3 and 2 stars began to accrete to form a very familiar set of objects, our own solar system. Let's move forward and learn more about this pivotal event. Thanks for watching, guys. Subscribe.
तो इस तरह से हमारा जो रिलेशन हुआ,
People had the idea our planet Earth to be at the center of the universe, as stated by Aristotle and Ptolemy's in their Ptolemaic, Aristotelian concept of the universe. According to this model, Earth is at the center of the universe, and all the other celestial bodies orbit around it. Today, lots of people think the same, but is this really the case? To answer this question, let's try to travel in the universe through space and time. We will start our travel from our planet to reach, in the end, the extreme boundaries of the universe. During the 1600s, Galileo Galilei, the famous Italian astronomer, was one of the first people during modern age to have some doubts about the geocentric model of the universe. Thanks to telescopic observations, he was able to demonstrate our Earth is not at the rotation center of planets and the Sun, but really it is the Sun itself. Moreover, observing planet Jupiter, he discovered that the giant planet is the rotation center for its moons. So Galileo became aware that the center of the solar system was the Sun, not the Earth. The solar system is made by a star, the Sun, 8 planets, and different types of minor celestial bodies like comets, asteroids, and dwarf planets. Well, the Earth isn't at the center of the solar system. Maybe it is the closest planet to our Sun. No, it isn't, because it is only the 3rd planet from the Sun. The closest planet to our star is Mercury, followed by Venus, and then Earth. The Earth moves around the Sun, our star, just like all the other celestial bodies in the solar system do. This implies that the Sun, and not our planet, is the center of rotation of the solar system. The Earth takes a year, 365 days to travel its orbit, and its average distance from the Sun is 150 million kilometers, which is the measured unit of distances in the solar system known as the astronomical unit, and abbreviated AU.
एस्ट्रोनॉमिकल यूनिट एक टर्म है, जिस तरह से लाइट ईयर टर्म है, द डिस्टेंस लाइट ट्रेवल इन 1 ईयर। एस्ट्रोनॉमिकल यूनिट डिस्टेंस है जो कि है आपके अर्थ से सन के बीच की डिस्टेंस, ऑलमोस्ट 150 मिलियन किलोमीटर्स है, 91 मिलियन माइल्स है, अराउंड 91 टू 94 मिलियन माइल्स। तो इतनी डिस्टेंस है, ये एस्ट्रोनॉमिकल यूनिट है। तो हम डिस्टेंस और यूनिवर्स में मेजर करने के लिए AU एस्ट्रोनॉमिकल यूनिट का भी यूज करते हैं. 1 AU मींस द डिस्टेंस बिटवीन सन एंड अर्थ, 2 means twice, 3 means thrice, and 4, 10, 100 times of AU, the distance between objects. We are using terms like this.
Why do we talk about average distance? Because the orbit traveled by the Earth around the Sun is not circular but elliptical. And this means that there will be an aphelion, i.e. the point of the Earth's orbit farthest from the Sun, just over 1 AU away from it, and a perihelion, the point of Earth's orbit closest to the Sun, just under 1 AU.
ये हम इन फ्यूचर देखने वाले हैं, पर दो टर्म है कि हम जानते हैं कि अर्थ जो है उसका पाथ सर्कुलर नहीं है, इलेप्टिकल है. तो जो एपिलियन आप देख रहे हैं, जो अर्थ जो पाथ सबसे दूर होगा अर्थ का वो एपिलियन है, और जो पाथ सबसे पास होगा वो पेरिहिलियन है. पास मींस पी पेरिहिलियन, और अपोजिट जो होगा दूसरा अपिहिलियन जो दूर होगा. राइट, इस तरह से आप याद कर सकते हैं, वरना कंफ्यूजन रहता है कि अपिलियन पेरिहिलियन कौन सा है. पर इन फ्यूचर ये पूरा की पूरा सीक्वेंस आने वाला है, हम तब बात करेंगे.
An alternative way to define the astronomical unit passes through the light time. In particular, we can say the average distance Earth-Sun is equal to about 8 light minutes. This means that sunlight takes 8 minutes to arrive on Earth, so that the sunlight we see at a certain moment is not that of that moment, but it is the sunlight which left from the Sun 8 minutes earlier. In other words, if the Sun went out, for example, at 2:30 p.m., we would only notice it at 2:38 p.m. Or again, if you could travel aboard the Star Wars Millennium Falcon, it would take you only 8 minutes to travel from the Sun to the Earth, when in reality it takes a few years. To give a more concrete idea of the dimensions of the solar system, if the Sun were a sphere with a diameter of 14 centimeters, Pluto would be at 700 meters from the Sun, like 7 regular soccer fields. The nearest celestial body to Earth is the Moon, our satellite. To reach it, you should take 3 days off. It's the same time taken by Apollo astronauts to cover the distance of nearly 400,000 kilometers that separate the Moon and Earth. But if you had Star Trek's Enterprise and travel at maximum curvature, you would only take less than 2 seconds to reach the Moon. Now let's begin to move towards the outer solar system. At a distance of 2 to 3 AU from the Sun, between the orbits of Mars and Jupiter, we would meet the asteroid's main belt. Asteroids are those small rocky bodies whose dimensions span.
हम बात मिल्की वे की कर रहे हैं, सोलर सिस्टम के एग्जिस्टेंस की कर रहे हैं, तो प्लीज थोड़ा टाइम पेशेंस रखिएगा. ये सब बीच में क्या चल रहा है इसके बारे में सब कुछ बात करने वाले हैं फ्यूचर. राइट,
And from a few kilometers to a few hundred kilometers. They are so small that they aren't visible through unaided eye, but only through telescopes. We could reach asteroids in a few years with a traditional spaceship or probe. Let's move on. We would need around 10 years and 40 AU to fly by Pluto, one of the outermost bodies of the solar system. Try to imagine it in your mind. If you were on Pluto's surface and had to look at our planet, you would only see a pale blue dot. That is the same sight captured in 1990 by Voyager 1 NASA probe, while it was leaving Neptune behind. Around Earth, only the dark vastness of the universe, barely illuminated by starlight. Now we have left behind our solar system, and we are going to enter the interstellar space. To get to Proxima Centauri, the closest star to Earth, we have to cover a bit more than 4 light years. We remember a light year is the distance covered by light in a year in the vacuum and is equal to about 10,000 billion kilometers. Distances begin to become big, since the Millennium Falcon would take more than 4 years, traveling at light speed to reach Proxima Centauri.
Proxima Centauri
Discover it, but it is a very, very long trip, so you will need much patience. The Milky Way is our galaxy. It is an immense group of stars held together by the force of gravity. It has the shape of a flattened disk with a bright core in the center, where the star density is very high, and spiral arms around it. Around the core, there is a spheroidal halo, which extends outside the galactic planet. At this point, it could be useful to introduce the parsec, equivalent to 3.26 light years, to measure the dimensions of our galaxy. So our Milky Way has a diameter of around 30,000 parsec, which are equivalent to 100,000 light years. So if we were back on the Millennium Falcon again and had to cross the Milky Way from one side to the other, traveling at the speed of light, the fastest thing there is, it would still take us 100,000 years to cross it all. Or to put it another way, if you were to send a WhatsApp message to your friends on the other side of the galaxy to decide what to do on the weekend, your message would take about 100,000 years to arrive. Assuming that your friends respond immediately to the message, the response would take...
कुछ ज़्यादा ही बोर कर रहा था